The may be true or can be true questions. The standard question is on the lines of which of the following may be true, and you would be given certain choices. The correct approach for solving these questions is to get just one case where the given condition is met. When you get even one true, you can select that option. When you fail to get even one case, it means that you need to eliminate that answer choice. Let's take an example. Which of the following can be true? And look at this case now. The approach is that we need just one case where such a condition is possible. So imagine for a value such as x equals 0.1, x cubed would be the smallest, then x squared, and then x. Of course, this will not hold for a lot of values, but that is not important. In these may be true or can be true questions, we need just one case in which the condition is met to select that particular option. So this option should be selected. Look at this. Again, there will be a lot of cases when this condition would not be met. They are not important. We should try to get just one case where this condition can be met. And imagine, for a small negative value, such as say negative 0.1, see x would be most negative, x cubed would be lesser negative, and x squared will be positive. So this is also possible. Let's take one more example. When do you think x squared will be greater than x to the power of 4? This would be the case when x is a small negative or positive number, such as, say, x equals 0.1. This condition would be met, and for x equals negative 0.1 also, this condition would hold. But see, in either case, x cubed will not be greater than x squared. In this case, x squared will be greater. In this case of negative 0.1, x cubed would be negative, and therefore x cubed would be the smallest of the three. So see, for this case, we are not able to get even one case where this condition can hold. Therefore, we must eliminate this answer choice. Sometimes the question is on the lines, which of the following cannot be true? So such cases where you fail to find even one case where this could be true would then be selected because this is the one which cannot be true. Let's take one more case. Once again, our approach is going to be the same, that we need just one value for which the two conditions can be met. Now it's given that x is greater than x squared. When do you think this is going to be true? Of course, not for negative values. Of course, not for large positive values. This is going to be true when x is between 0 and 1. Again, an example such as 0.1. But in such cases, x would not be greater than 1 divided by x. In fact, 1 divided by x would always be greater than x in such cases. So once again, we will not be able to find even one case where this can be or may be true. Therefore, this option should also be eliminated. So this is the approach for may be true or can be true questions. Let us now look at must be true or should be true or always true questions. The standard question is which of the following must be true? The approach is that in these questions, try to get just one case where you are able to prove a statement false. When you get even one false, you can eliminate that answer choice. When you can't get even one false, that means that answer choice has to be selected. Let's take an example. Which of the following is always true? Look at this one. Our approach should be that we should get just one false case. We know that 1 divided by x is greater than x. When is this possible? When x is between 0 and 1, a small positive value, or when x is a big negative number, such as, let's say, when x equals negative 5. So we take an example, 0.1, and we take an example, negative 5. So see, x is greater than x squared will apply in this case, but it will not apply in a value such as negative 5. So we have a case when x equals negative 5, that 1 divided by x, which is negative 0.2, is greater than x, which is negative 5. But x is not greater than x squared. X squared is positive. Therefore, we can eliminate this option. Once again, the approach is that we try to get just one case where we are able to say that a statement is false. We eliminate that answer choice and we move on. When we are not able to get even one case, it means false is not possible. The statement is going to be always true. One more case. If x is greater than 1 divided by x, 2x is greater than x is greater than 1 divided by x. When is this possible? This is possible for big positive values, say x equals 5, but it is also possible for small negative values, say x equals negative 0.2. See, negative 0.2 would be greater than 1 divided by negative 0.2, which is negative 5. But in the other case of negative 0.2, 2x would not be greater than x. So once again, we got one case where we could say that yes, x is greater than 1 divided by x, but 2x is not greater than x. Therefore, this statement is false. We got only one case where we could say that the statement is false, and we can eliminate this one. One more. It's given that x is greater than 2x. When is this possible? Of course, when x is negative. Okay, now 1 divided by x is greater than x. Look at this. If we take x equals negative 0.1, see x is greater than 2x, yes. But 1 divided by x would become a big negative number. It would become negative 10, which would not be greater than negative 0.1. So once again, we have got one case where we could say that this statement is false. If you are wondering how I am choosing such values, negative 0.1, negative 0.2, all of these, I have taken this up in detail in our inequations videos. You may want to watch these conceptual videos. One more example. It is given that x squared is greater than x, and we want to prove that x cubed is not greater than x squared. You want to have a case of false here. Of course, if you take some negative value of x, say negative 2, x squared will become 4. The first condition has been met, but the second condition would not be met because x cubed would be something negative, and this would not be greater than positive 4, the value of x squared. So even this should be eliminated. We got one case of false, and we can say that no, the statement is not always true. Let's look at the fifth one now. X is greater than 1 divided by x. When is this possible? When either x is a big positive value, such as x equals 5, then x is greater than 1 divided by x, or x is a small negative value, say something like negative 0.1. See, x is going to be greater than 1 divided by x, as 1 divided by x will become a big negative number, and in both the cases, this is going to hold. That x squared is greater than 1 divided by x. See for 5 also, and for negative 0.1 also. In this case, we will not be able to get even one false. So we can't get even one false. That means this statement must be always true. So this is the approach for solving the must be true, should be true, or always true questions. Largely, they are all the same. This was the concept, friends. GMAT shots are deliberately kept brief. For an elaborate explanation, please watch the Stage 1 conceptual videos in our program. Thanks for watching.